Okay, so let's proceed to your definite integral. So if you're going to look at your screen, so we're going to have two different fundamental theorem of calculus. So in the first one, so it's clearly what we have discussed so far in our indefinite integrals. So as you can see in the second line here, so we have the derivative of your g of x. So it gives us your f of x. So if we try to integrate this one, so it goes back to g of x. So that's what we did so far in our discussion, in our techniques in integration. So if you want to verify that your answer is correct, so we have to derive the answer. So that's why we have g of x prime is equivalent to the function of x, in which what we have derived, in which we have integrated so far in our discussion. So just try to ignore the first line because the important part in the fundamental theorem of calculus in the first one is this second line here. So for the definite integral, so this is what is most likely what will happen in your equations. So this one here. So as you can see, so if we try to eliminate a and b first, the limit of integration. So the answer is not f of b minus f of a, but it's the function of x, the big F of x, plus c, as per basic definition of indefinite integral. Now, if we add limits of integration, so let's say we have the lower limit a and the upper limit b. So that's the individual functions of both limits. So this one is the lower limit, and this one is the upper limit. So since we are now dealing with definite integrals, so those integrals having limits of integration, so after getting this one, after integrating your equation, so what we will do next is we will be applying the value of the limits. So first with the upper limit, so apply the upper limit in the function of x. So of course we try to ignore c as of this moment. So eliminate c now because we'll be dealing with an exact value of your integrals. So applying your upper limit first in the answer of your integral, then minus the lower limit. So you apply it again here in the function of x. So that's why you have f of b minus f of a in the integral of f of x dx from a to b. Okay. So again, the first thing that you need to do is you integrate. So since we know how to integrate our different functions, we have many techniques that you have learned. I think you can integrate your functions as of now. So after integrating is you then now apply the limits of integration. So apply the limits. So that's the only new thing here in your definite integral. So you just apply the limits of integration. So the answer for these are an exact value. So it may be a whole number, it may be a pi, so on and so forth. So it's an exact value. So it's not the same as your f of x plus c anymore. So there's no plus c anymore in your definite integral. So most likely, why do we need to learn your definite integral? Because in the second half of semester, so we will be dealing with your applications of your definite integral. So we'll be going to area, volume, surface area, work, liquid pressure. So all of those applications require your definite integral. So for you to appreciate the process of determining the definite integral, so let's solve the examples after this slide. So let's go first to the properties of your definite integral. So as you can see here, it's just the same as your indefinite integral. So if you have a constant in your integral, so you can remove it outside the integral symbol. So the same as your indefinite. So if you have binomial, so you can separate them into two different integrals by distributing dx. Okay, so familiar properties coming from your indefinite integrals. So also for adding intervals, let's start first with the reverse interval. So if you have this function from a to b, and then let's say you want to get a negative value or negative operation for this particular integral. So what you need to do is you get the negative symbol and then you just reverse the limits of integration. So as you can see on the left side, it's positive from a to b. Then it's equivalent on the right side. So you have negative, but the limits of integration is now b to a. So why do we have this property? Why do we have this property? So most likely the purpose of this property is for a simplification process, or let's say you want to group together integrals or you want to simplify integrals. So this is the purpose of the reverse interval property. So next is you have the zero length interval. So why it's called zero? So the value of this one is zero because the limit is from a to a. So it has the same lower and upper limit. So again, as per formula from the previous slide, so that's f of b minus f of a. So that will be the upper limit minus the lower limit. So the upper limit is a, the lower limit is also a. So f of a minus f of a will be equal to 0. Okay. Then lastly is your adding intervals. So in adding intervals, so in this property, you can combine the two terms in such a way that the given interval is connected. It can be connected. So let's say b to b. And then also your given equations are the same. So that's the time that you can combine your two different integrals. So you can add intervals if the upper limit of the first term is the same as the lower limit on the next term, and also the functions are the same. So as you notice, the final answer is now from A to C. So A to C, and then A to C. So of course, the properties that are presented in your screen are reversible, so you can combine them to the right side of the equation. You can convert the left side to the right side, or you can convert the right side to the left side, depending on the need that you're going to have in the simplification process. So those are the properties of your definite integral. So let's try to solve 5 problems. So as you can see, the only new thing here is you have your limits of integration. So in integrating, so I think it's not a new thing because we are integrating up until this point. So what we need to do next is just apply the limits of integration. Okay, so starting off with the first number. So again, we just integrate first. So in integrating, so I think you know how to integrate 4x and then negative 6x squared. So we don't apply the property anymore because we know that we are now advanced in analyzing the integrals of each term. So we can do a bit of a shortcut in getting the integrals. So the first one is 4, then times x squared over 2. That will be the first term. And then minus the second term, the integral of the second term, that will be 6 times x cubed all over 3. Okay, then simplifying is we have, so this will be cancelled out. Then what remains is 2. So also 2 on the second term. So cancel out 3. So this is 2x squared, then minus 2x cubed. So notice we don't put plus c because we're now dealing with a definite integral. So what do we need to do next is, after getting the final answer, is you write a long bar line on the right side. So in this manner. Then write the lower limit -1, then upper limit 2. And then you apply the formula. So that will be f of b minus f of a. So f of b then minus f of a. So again, the upper limit is your b component. Your lower limit is your a variable. So starting off with the upper limit, so apply the value of 2 in the answer of your integral. So let's try to separate the f of b and f of a through a bracket. So the first one is 2, then 2 squared, then minus 2 times 2 cubed. So again, this is still the f of b term. And then minus, so next is you apply the lower limit in the same equation. So this is 2 times -1 squared, then minus 2 times -1 cubed. So this is your f of a. Now, since we are not allowed to use our calculator during the midterm exam, so you'll be adding up the terms manually. So meaning you have to multiply, you have to expand manually. Okay, so the first bracket group will become, so 2 times 2 squared, that will be 8. And then 2 times 2 cubed, so that will be 16. And then mine, sorry. Okay, so the next bracket group will be 2 times -1 squared. So this will be 2. And then minus 2 times -1 cube. So -1 cube is -1. Then times -2. So this will be +2. So you have -8 and then -4. So the final answer is -12. So that is your answer of your definite integral. So super easy na kayo siya, di ba? Because you'll be just applying the limits of integration. I think the only problem here is since you'll be doing this manually, so most likely you'll the difficult part is in the algebra. So you have to be very careful with applying the signs, retaining the symbols, then multiplying small numbers. So you have to make sure that every term is correct and every operation and sign is also correct. Okay, so do you have questions for the first example? So I think it's super easy, diba? What you need to deal here is the integral process first. So if you're given a difficult integral, so that will be a hard time for you because you cannot reach the process of applying the limits if you can't integrate the equation first. All right, so let's proceed to number 2 since there are no questions. So this time is we have the integral of x to the power of 1/3 plus x to the power of 4/3 dx from 1 to 8. So again, we always start off by getting the integral of the individual terms. So since we have two terms, so we'll be getting the integral of x to the power of 1/3, and the next one is the integral of x to the power of 4/3. So the first one is x. So 1/3 plus 1, so that will be 4/3. So all over 4/3. Then plus x to the power of 7/3 all over 7/3. Okay, so I hope by now you're now quick to add fractions. So if you add a whole number to a fraction, so you'll get the answer immediately. So simplifying is we have 3x to the power of 4/3 all over 4, then plus 3 times x to the power of 7/3 all over 7. So again, we write the limits of integration on the right side of the long bar. So you have 1 to 8. Okay, so applying the limits of integration. So again, the formula is f of b minus f of a. So again, starting with the lower limit, so this becomes 3, then times 8 to the power of 4/3 all over 4, and then plus 3, then times 8 to the power of 7/3 all over 7. So again, this is still f of b. Then minus f of a. Again, this is f of b. So f of a is 1. So 3 times 1 to the power of 4/3 all over 4. Then plus 3 times 1 to the power of 7/3 all over 7. So if we try to convert this one into its radical expression so that we can try to observe if we can simplify the term inside your cube root function. So this is 3, then times the cube root of 8 to the power of 4. Then plus, again, converting it to its radical expression in square root expression. So cube root of 8 to the power of 7 all over 7. Then the other one is the same. So 3 cube root of 1 to the power of 4 all over 4 plus 3 cube root of 1 to the power of 7 all over 7. So notice on the f of a term, so this one is our f of a. So in our f of a term, so the cube root of 1, so maskin pila pa siya ka 1, so if you have many 1 inside your cube root function, so the value of which is still 1. So this one is equal to 1, and then 1 to the power of 7, then cube root of 1, that's still 1. Okay, so what's left here is just 3/4 plus 3 over 7. So let's try to evaluate the right side, the left side, the f of b term. So we have 3 and then cube root. So we know that your 8 is a perfect cube, so 2 times 2 times 2 is 8. Now since we have 4 8s, so we can already simplify this into its different cube function. So again, since 8 is a perfect cube, so we can eliminate the cube root function or cube root expression in immediately. So this is times. So again, so since there are 8 fours, 8 times 8 times 8 times 8. So again, each 8s are a perfect cube. So the cube root of 8 is 2, and then again, since we have 4 8s, so times 2 times 2 times 2, di ba? All over 4. Or if you don't want that method, so you can always express this also in this manner. So 8 cube, then times 8. So 8 cube is a perfect cube, that is 8. And then 8 is a perfect cube, so times 2. Okay? So you can do that as well. So for the second term, so let's try to solve it in this manner. So 8 to the power of 7. So we can have 8 cube times 8 cube, then times 8. So that will be 8 times 8 times 2 all over 7. So again, the right side is just 3/4 plus 3 all over 7. So simplifying even further, so 3 times 2 times 2 times 2 times 2, so that will be 16 times 3. Sakto ba? So 6. So 16 times 3 is 48 all over 4. And then plus, so 64 times 2, that's 128 all over 7. And then minus 3/4 plus 3 over 7. Okay, so 48 over 4, that will be 12. So 12 plus 128 over 7. So if you can try to simplify 128 over 7, so I think it's not divisible by 7, so let's try to keep it that way. Hmm? Ah, yeah. Oh, sorry. So there's a times 3 there, so forgot. So thank you for that one. So instead of 128, so times 3 pa jud. So this becomes, so 128 times 3, so that will be, so 300, no? So 300 something. So 384. So sakto ba? So 128 times 3. So since we are solving it manually, so 8. So yeah, it's 384. Then the right side is 3/4 plus 3 over 7. Okay, so in quick adding of fractions, so can do the crisscross method. So crisscross method. So same goes on the right side. So this becomes, so 12 times 7 plus 384 all over 7. Then minus 3 times 21 plus 4 times 3 all over 28. So 12 times 7, so that will be 84. So 84 plus 384. So that's 84 plus 384 all over 7. Then minus, so this is 63. Then plus 12 all over 28. So we now have, so 384 plus 84. So that will be 468. So I think this one is still not divisible by 7. So this is divisible by 7. Then this one is 75 over 28. Okay, so if we're going to add this up, so since there's no space, so I think you just, so just continue this on your own. But the answer for this one is, you can try to get the LCD. I think the LCD is 28. So the final answer is 179 all over 28. So that's the final answer. So just try to subtract this manually. So the integral part is difficult. Then the difficult part in applying the definite integral or the limits of integration is algebra, since we are not allowed to use our calculators. All right, so questions so far for this example? Yes. 3 times, yes, it's 7 there, it's 7. This one is 7 there, so that's correct. So na-advance ang mind. So i-multiply tayo ng kuan. So let's try to change the answer. So this one is 7. So this one is 21. Then this one is 33. So it's 1839. Okay. So di ba hasta ako nagsayop sa algebra, di ba? Usually if your mind is very fast in answering the problems, and then ang pagsuwat ninyo kay awahi. So so just verify your solutions if you have time. Okay, so thank you for that one. So if you don't have any more questions for this item, so I think we can proceed with number 3. So this time is we have a simple integral of 3 sine x dx from 0 to pi. So if you try to integrate this one, so getting the constant outside, so we have sine x dx. So again, the integral of sine x is negative cosine x. So this becomes 3 times negative cosine x plus c. So again, since we are dealing with a definite integral, so there will be no plus c here. So the final answer is negative 3 cosine x. Then apply the limits from 0 to pi. So this may sound simple. So cosine x. But again, since we don't have any calculator, again, let's try to apply first the formula. So this one is A. So starting off with f of b, so this is negative 3 cosine of pi. Then minus negative 3 cosine of 0. So again, f of b and then f of a. So again, since we don't have any calculator, we cannot determine the value of cosine pi. So if you have learned your quadrantal angles, so you know the shortcut for the values of your quadrantal angles in your trigonometric functions. So again, if you try to draw the coordinate system, so quadrantal angles are your angles in the axis, so 0 or 360 degrees, then 90 degrees, then 180 degrees, then 270 degrees. Or in terms of pi, so this is 0 or 2 pi, this is pi over 2, this is pi, this is 3 halves pi. Okay. And then 2 pi, di ba? So again, quadrantal angles, if you have memorized such from your trigonometry class, from your triangle class, so the cosine function in the 0 angle is, so again, cosine function. So cosine function here is positive 1. And then cosine 90 is 0. And then cosine 180 is negative 1. So this one is, let's try to make it even clear. So 1, so positive 1, 0, negative 1. Then going back to 270 degrees, so that's still 0. Then positive 1 for 2 pi again. So if you know this, so you can answer the given equation in so given equation here. So that will be negative 3. Then again, cosine pi is negative 1. So negative 1. And then minus 3. Then negative, oops, sorry. So this is minus negative 3. Then cosine 0 is 1. So times 1. So this is positive 3. Then minus negative 3. So the answer is 6. Okay, so do you have questions for this example? Okay, so let's proceed to the next. So let's say you have this example here. So it may seem complicated to you, but again, if you just explore your techniques, so you'll be able to solve this integral. Okay, so upon observation, so you may say that you're going to use advanced technique such as algebraic substitution, but you can just simply use u sub here. So of course, you don't know that it's u sub unless you try to do some trial and error method, diba? So go from the basic concepts first of integration. Then if the basic process don't work, so that's the time that you apply the advanced techniques. So x squared plus x. Okay, so getting the derivative. So derivative of u is equal to 2x plus 1 dx. So notice that this one is the term here, 2x plus 1. Then the u is the term inside the radical expression. So the equation becomes from 0 to 4. So square root of u du. So making it in exponential form. So from 0 to 4, then u to the power of 1/2 du. So the answer is u to the power of 3/2 all over 3/2, which gives us 2u to the power of 3/2 all over 3. So bring back the value of your u parameter. So that will be x squared plus x raised to 3/2 all over 3. Then apply the limits of integration from 0 to 4. So again, that will be f of b minus f of a. So upper limit first, then minus the lower limit. So that will be 2. And then, so applying the 4 first. So this is 4 squared. Then plus 4. Then raised to 3/2 all over 3. And then minus, so 2 times 0 squared, so plus 0, raised to 3 halves all over 3. So why did I put 0? So even though I know that it's 0, so just try to evaluate the 0 limit because we don't know that it's really 0. So for example, it's x squared plus 1, so that will be 0 squared plus 1. So it's not totally 0 because the one term is only 0. So 0 plus 1 is still 1, diba? So it's not a 0 value. So here that's 0 squared plus 0. So we can clearly see that this one totally gives us 0. But because 0 divided by 3 is 0. Okay, so what we need to evaluate now is the first term. So this becomes 2 times, so 4 squared plus 4. So that will be 20. So 23 halves all over 3. So in radical expression, so this becomes 2, then the square root of 20 cubed all over 3. Okay, so I think the simplest method for this one is you, since we are evaluating it manually, so the simplest method that I can show you is in your 20, so make it in its individual factors. So the factor of 20 is 4 and 5. So I chose 4 and 5 because 4 is a perfect square instead of 2 times 10, diba? So 2 is not a perfect square, 10 is not a perfect square, so I cannot eliminate something inside the radical expression. So I chose 4 times 5 and then cube, diba? So I think it's the same thing. Okay, the next is we try to distribute your cube to individual factors. So that will be 4 cube then times 5 cube all over 3. So notice we can now express this one into its individual terms, so such that we can try to eliminate components inside the radical expression. So instead of 4 cubed, so I can say it's 4 squared, so that I can take it outside. So then times 4, then times 5 squared, then times 5. So perfect square, which gives us 4, perfect square, which gives us 2, and then perfect square, which gives us 5. Excuse. So this is 2 times 4 times 2 times 5, square root of 5 all over 3. So the final answer is so this is 80 square root of 5 all over 3. So am I right? So 2 times 4 is 8, 10 times 2 is 16, 16 times 5 is 80. All right. So I think what another tip that I can give you here is, for example, you don't know which particular technique you're going to use. So I think what my best tip for you here is apply U sub first. So if it can be solved using U sub, so that's an easy integral there, diba? But if cannot be solved using U sub, so you need to try other techniques of integration. All right. So do you have questions for this one? Okay, so let's proceed with the last example. So again, starting with a basic U sub, so you always try to use U sub. So notice that uh, the exponent here is 3. Paano mo siya out? So notice that the expression here is x cubed 2x. So again, in the earlier topics that we have discussed in the first, I think in the first video, in the basic integrals. So always let u be the term having the exponent, diba? So this will be sine 2x. Okay, then the derivative of this one is 2 cosine 2x dx. So notice that we have cosine 2x dx here. So isolating 2 or dividing everything by 2. So you have d over 2 cosine 2x dx. So the integral becomes from 0 to pi over 4. Then this one is u cubed times du all over 2. So taking the constant outside, so we now have 1/2 integral of 0 to pi over 4. Then u cubed du. So we now have 1/2 times u to the power of 4 all over 4. Then you have u to the power of 4 over 8. Then bring back the value of the u parameter. So we have sine to the power of 4 2x all over 8. Then apply the limits of integration from 0 to pi all over 4. So starting off with the upper limit, so again, f of b minus f of a. So f of b is pi over 4. So for us to easily see if the exponent, so we can try to write it in this manner. So sine, then 2 times pi over 4, then to the power of 4 dayon. Okay, all over 8. And then minus, so again, sine times 2 times 0, then raised to the power of 4, all over 8. So this one is f of b, this one is f of a. So cancel out 2 here. So we now have sine pi over 2. So again, going back to your quadrantal angles, so if you have the sine function, so starting off with 0, so 0, 90, 180, 270. So pi over 2 is 90 degrees. So starting off with the 0, so sine 0 is 0, sine 90 is positive 1, sine 180 is 0, sine 270 is negative 1. So this is 1 raised to the power of 4. So 1 raised to the power of 4 all over 8. Then minus sine times 2 times 0. So sine 0 is 0, diba? So that will be 0 to the power of 4. So again, this one is 0. So the final answer is 1/8. Okay, so I think that's all you need to learn in the definite integral. So you know how to evaluate your limits of integration. So again, since we are manually solving as of the moment, so you have to deal with the algebra stuff. But in the final exam, once we reach the different applications of the definite integral, area, volume, surface area, so I think you may now use your calculator. If you want to explore your calculators, I think it's the button for the definite integral is below the alpha button for 991 ES plus or 991 version for Casio. So the symbol for the calculator for definite integral is in this button here. So if you try to press that one, so what will appear in the screen is inertia and then dx. So you have to make your expressions in x. So alpha x squared. So let's say this one is sine 2x, then sine 2 alpha x, then cube cosine 2 alpha x, then from 0 to pi over 4. Right? So that's it for the discussion.